Hi students, hope you all fine. So today we are going to discuss about correlation coefficient. So we all know that correlation is nothing but it is the relation between two variables. Now we are going to discuss about correlation coefficient. So the correlation coefficient is a numerical value, okay, numerical measure, or else we can say that numerical value. Okay, so the first point is the correlation coefficient is a numerical value, numerical measure we can say, or else value we can say, numerical measure that tells about strength and direction. Okay, so coefficient, what it tells about the strength and direction. Strength is nothing but we can also say that it's a size. Okay na, between what, strength and direction of the relationship between what, two variables. Okay, relationship between two variables. Okay, yeah, so we use mostly correlation coefficient of Pearson. So that means what, correlation coefficient is denoted with R. We can say that correlation coefficient is denoted with R. Okay, so next point is the correlation coefficient is denoted by what, denoted by R. Okay, so this R is nothing but it is a Pearson R. That means correlation coefficient is introduced by Pearson, Carl Pearson. Okay, so that's why it is also called as Pearson R. Okay, so and the next is it lies between, it lies between -1 to +1. So that means symbolically we can write that, symbolically we can write that, that is nothing but minus r less than or sorry, -1 less than or equals to r less than or equals to +1 we can write. Okay, so now we are going to write what is the formula in order to calculate correlation coefficient, that means R. So what is the formula? Okay, we are going to discuss. Okay, so the formula for Pearson. So as we told that it was introduced by Pearson, no? So Carl Pearson. So the formula for Pearson's correlation coefficient is coefficient R, no, is R equals to covariance of x comma y by standard deviation of x into standard deviation of y. Okay, so if we want to know this one in theoretical, we can say that this formula in the form of theoretical, we can say that Pearson's correlation coefficient is the covariance, is the what, covariance of two variables. Yes, now here we are having x and y, so that's why we say that two variables divided by, so if we write like this, so what we call it as divided, so divided by product into form. It is in the form of into, no? So that's why we can tell that product of their standard deviations. Yes, no? So sigma x, sigma y are nothing but these are the standard deviations, isn't it? So this is the meaning of this formula. Okay. So as we discussed that it was introduced by whom? Carl Pearson. Okay, na? In the year 19. Okay, so Carl Pearson developed the formula. Okay, so later it was introduced by Francis Galton. Okay, later it was introduced by, we can say that, Pearson. A related idea, so that means the same idea, a related idea introduced by, or else we can say that it was later followed by Francis Galton. Okay, in the year in the year 1880s. Okay, so this is about correlation coefficient. So now we learn about what is the formula of correlation covariance of x comma y by standard deviation of x into standard deviation of y. Okay, so now we learn about it. So R of x comma y equals to, what is the formula? Covariance of x comma y by standard deviation of x into standard deviation of y, isn't it? So where covariance of x in terms of expectations, we all know that in terms of expectations covariance formula is expectation of x minus expectation of x comma y minus expectation of y. Okay, so now we have to multiple these two. This is x into y. Okay, expectation of x into y is nothing but xy. Again, x into minus expectation of ey is minus x into expectation of y. Again, minus expectation of x into y minus y into expectation of x. So minus into minus plus. So plus expectation of x into expectation of y. Okay. So now what we have to do? We have to multiple this expectation with all these terms. So xy into expectation is nothing but expectation of xy. So already we are having here expectation. So that's why we have to add only for this. So expectation of x into expectation of y. Again here we don't have, here we are having. So only here we have to add. So minus expectation of y into expectation of x. Okay. And the next is expectation, already we are having. So plus expectation of x into expectation of y. So here negative sign, here plus sign. So this both gets cancelled. So the remaining term is expectation of xy minus expectation of x into expectation of y. Okay, so this is the formula for what? Covariance of x comma y in terms of expectations. So this we can write 1 by n summation xi yi in terms of x and y minus, this is mean, expectation of x is nothing but x bar, expectation of y is nothing but y bar. Okay, so this is covariance of x comma y formula. Okay, so now what we have to do? We have to find out this. So standard deviation of x is standard deviation of y. So standard deviation of x, that means we do first variance. So sigma square x in the sense what? Expectation of, in terms of expectation the formula is expectation of x minus expectation of x whole square. So that equals to expectation of x minus expectation of x in the sense what? Mean. So mean is denoted with what? X bar. Okay, whole square. So this is nothing but here expectation of x. So that means what we can write? 1 by n summation xi minus x bar whole square. Okay, na? So similarly we can write sigma square y equals to 1 by n summation yi minus y bar whole square. Okay, but what we want? We want only standard deviation of x, no? So that's why square root of 1 by n summation xi minus x bar whole square. So here also standard deviation of y equals to square root of 1 by n summation yi minus y bar whole square. Okay, so now this standard deviation of x is standard deviation of y covariance we have to substitute in this formula. Okay, so we'll substitute in this formula. So that means r equals to covariance in the sense what? 1 by n summation xi yi minus x bar y bar whole by square root of 1 by n summation xi minus x bar whole square, again square root of 1 by n summation yi minus y bar whole square. So this is the formula for what? R in the sense what? Correlation coefficient in terms of what? X and y. Okay, so this formula we can also write in another way, that is nothing but r equals to one second. Here we are having 1 by n, 1 by n, no? So we can write in a single term, that is nothing but, or else you can leave like that only, 1 by n summation xi yi minus x bar y bar whole by square root of here 1 by n, here 1 by n, 1 by n. So that means what? 1 by n square summation xi minus x bar whole square, again summation yi minus y bar whole square. So like this also you can write this formula. Okay, now which formula? This formula we can write. Okay, so in this way also. So this is the formula for what? Correlation coefficient. Okay, so hope you all understand. So if you are newly watching my channel, please subscribe to my channel for latest videos, and also please comment which type of videos you want so that I will make the videos. So thank you for watching. Have a nice day, and don't forget to subscribe, share, and also comment, and also like. Okay, bye, take care.